a lot of complicated parts. It's like a car. And so you want to have your basic building blocks that are almost like Legos, but you also want to be able to combine those. So block diagrams show you how you combine these things. So as an example, here is a block diagram that I could draw. I could say I take my message, I run it through a Caesar cipher, and I get my ciphertext. Now that's a really simple block diagram. Is this complete? Is this enough information to know what's going to happen when I put in my message? No, what's missing? I need the key. I need to know which actual Caesar cipher, because there are actually 26 different Caesar ciphers. So the key is also going to be input. Now the reason that this is useful is, and Caesar is a box. These are like mystery boxes, but my box here is going to combine this information, and I just assume when I make this diagram that I know what this means and that it can produce the output I'm asking it to produce. The cool thing is, we talked in the past about composite ciphers. So if you're doing a composite cipher, you can do it as a sequence of ciphers. So what if I take my message and my key and I run it through a Caesar cipher? Well, can I take that and then run it through an @bash cipher? Can I take the output of the Caesar cipher and run it through an @bash cipher? And then can I take the output of that and have it be the output? And I'm going to be doing this for lots of different. What if I looked at this? What if I split the message in half? I take the first half and I put the first half into a Caesar cipher with whatever key. And I take the second half and I put the second half in an @bash cipher. Well, I'm going to need a way to split my message up. Well, can I make up an operation, or a function rather? A function that just takes the first half of a message? Is there anything that says I can't do that? So I'd have my message, and it would go into two different things. There would be a block called first half. There would be a block called second half. And then in first half, I'm going to need a key here. Put the key in right here. That's fine. Second half is going to go through @bash. Now, what am I going to do with the Caesar output and the @bash output? Concatenate. So I'm going to put these back into a block called concatenate, because I need to take the two separate messages and just push them back together, and that will be my message, my ciphertext. So this way of combining these information processing things called block diagrams, every person who does this develops sort of their own dialect. So like a person might have, this is how it would work. If you have the basic building blocks, you can start combining them. And then you can say things, well, like, what if I did an @bash and a Caesar here instead of just an @bash? And it gives you a way, writing it out this way, gives you a way of analyzing it. And so that's a good thing to know how to do, how to create a block diagram that represents some kind of information processing thing. You can almost think about this like pipes. You're connecting pipes together. The only difference is that when you connect the pipe, what goes into the pipe is different than what goes out of the pipe. But you're plugging in things to each other. It's just like electronics. Now, let's imagine that we did a composite cipher. That's the kind we just talked about. So if we had a composite cipher and we have our message that goes in, our plain text that goes in, and we're going to do a key here. We're going to go into a Caesar cipher. And after Caesar, we're going to go into an @bash cipher. I'm going to say Caesar encrypt, because encrypting and decrypting for Caesar are different. Even though encrypting and decrypting for @bash are the same, I'm also going to say that, and then I have my output, or my ciphertext. So this is my encryption process. And if I wanted to write out this encryption process, I could write it out like, first encrypt the message with the given key using Caesar cipher, then take the output of step 1 and encrypt it using @bash, and then you're done. Output from step 2 is your ciphertext, or your output. That's in words what this diagram is saying. Does that make sense? Here is the crucial thing. When I go to decrypt, the order in which I encrypted was Caesar then @bash. When I go to decrypt, what order will I use the steps to decrypt? @bash then Caesar. Do y'all agree? So you can just run this backwards, because your goal is to get from your ciphertext back to your plain text. So you run the arrows backwards in that order. So you start with the ciphertext, and you just changed every encrypt to decrypt. Now I need to be sure I have the key to put in here. Now I need to go back to my plain text. So if someone has the block diagram of your encryption, then to do the decryption, they just run everything backward. But what does this have to do with math? First of all, this is a type.